Hi guys, it's Jason here. Today we're looking at one of these. It's the Marshall SV20H. I'm sure you're familiar with the amp. Now this has come in for a Jose high gain style mod. Okay, it's brand new in the box. It was actually shipped to me directly from a retail store here in Australia. But before I get into the Jose mod, which I'll do in a part 2 video, this part 1 video, we're just going to do a bit of a deep dive on this amp. And I want to see if I can make some improvements to it in terms of a stock plexi circuit, right? Over the years, right, through the 60s and into the 70s, Marshall changed a number of values and a couple of the sort of subtle changes in the kind of standard 4-hole plexi circuit. And I believe that some of those implementations of the plexi were better than others. And this one is a bit of a mix of a few of them. And I want to see if I can make a couple of subtle changes to this and see if I can get it sounding at its optimum before we then progress into the high gain style mod. So I'm going to record some tones with this using the looper on my Axe effects like I normally do. We will make the changes to the circuit, keep it as a plexi, re-record the looper, or kind of reamp it, I guess is the way to think of it, and do an A/B sound test. And I'll take you through on the bench and explore the changes that I've made. Stick around. Okay, here is the SV20, the head, right? It's obviously a 4-hole plexi, and it's pretty true to the originals. As I said in the intro, it is a particular era, I guess, that they've gone for, which I think can be improved just in terms of being more articulate and probably a little less harsh. And I just want to give a quick overview of kind of how this thing's set up. So if I tilt this forward, you can see the pots here, PCB mount, which is fine, and all the values which are printed on the tops of them. Total legit plexi, right? To 1 meg audio taper for the volumes. Tone stack is completely what you'd expect to see in a Marshall. 5K presence pot. So first of all, I just want to talk about how V1 is set up, right? Because this is an area where I will be trialing some changes to improve the sound of this amp. Now, the cathode resistors in this guy are 820 ohms. Okay, so here's my meter, and I'm going to measure this one. You see, 815. Let's call it 820. Here's the other. There you go. Okay, so look, 820 ohm cathode resistors were used in Marshalls, right? You'd see this in the, the Marshalls of the, kind of 100 watt super leads of the late 60s. It means that the gain stages here are very kind of warmly biased, so and I think tonally this can sound a little bit fuzzy. Yeah, definitely played with this, right? you get quite a lot of gain the way this is set up, but it can sound a bit fuzzy. And with this amp, trying to get a little more clarity out of it, and as I said, tame some of the harshness. So I'm going to be moving these to 2K7, which is the value that Marshall adopted a bit later on. And I think an amp like this particularly will sound better, especially as the voltages in this amp are pretty low. Right? I will talk about kind of the power scaling and what Marshall have done here to get 20 watts out of a pair of EL34s. But that's the first change we're going to make. The second change is that the cathode resistor for V2A, this guy here, also 820. This is very common. I'm not going to change the value of this, but I am going to put a cap across here. And we definitely saw Marshall starting to do this with a 0.68 microfarad bypass cap on that V2A gain stage. Really kind of starts to fatten up the sound. But I'm going to go higher than that. I'm probably going to try 22 microfarad, which I do. You would have seen me do that before. Really kind of fattens up the mid-range. So I'm going to try that. And I'm going to tame a little bit of harshness at this point of the amp, probably with a plate snubber cap over this plate resistor here. But we will try all that. If that doesn't kind of have the desired effect, then I might try it on the 100K cathode resistor. But we'll see. I often prefer it here, actually, just tonally. So let's talk about the power stage and the power scaling in this thing. And I will measure some voltages to show you how this is kind of all set up. It is a cathode bias amp. Okay, it's not fixed bias. The 50 watt origins, which are kind of, let's just say they're from the same factory in terms of the manufacturing, are genuine fixed bias amps. These are cathode bias, which, obviously the plexis, both 50 watt and 100 watt plexis that we know and love, were not cathode bias, they were fixed bias. So this big 5 watt cement resistor here, 150 ohms, so this is the cathode resistor for this guy. These are screen resistors you normally see, 5 watt 1K. There's another 5 watt 150 ohm resistor here. This is the, instead of a choke. Okay, so you could actually improve the sound of the amp by implementing a choke, and you'd cut this resistor out and you'd wire the choke on either end of the pads in the PCB that are left. In a low wattage amp like this, look, you get some improvement from adding a choke, but it's kind of marginal. So I can understand why Marshall didn't implement a choke in this amp. Now, in terms of the power scaling, what's kind of interesting here is the way that they've set it up. So the power scaling will reduce the voltage to the EL34s, which are here, and also the voltage to the phase inverter. Now, what you would normally see, I'll kind of refer to a schematic perhaps, but what we would normally see in these kind of Marshall style amps, and in fact most amps, is your B plus supply line kind of cascades all the way down the amp. So you set up the B plus line, which is giving you a plate voltage on your power tubes. They go through the choke, which then gives the power to the screen nodes, then through a drop-in resistor or two for the phase inverter supply, then through another drop-in resistor for the V2 supply and another drop-in resistor for V1. It cascades all the way. Marshall haven't done that with this amp. They've broken or branched off the B plus line so that you can control the voltage that the power tubes and the phase inverter are getting, and they will drop together when you go high mode, low mode. But the preamp supply is isolated from that completely separately. Let me see if I can just demonstrate that with some continuity testing. So this side of this resistor here is the rectified and filtered B plus. Okay, so this is going across over here to the center tap of the output transformer, okay, which is delivering the plate voltage to pin 3 on the power tube. So that's all kind of as expected. And from there, we're going through this, you know, choke. Let's call it a filter choke. It's not a filter choke, obviously, but it simulates that. It's a drop-in resistor on the B+ line. And this is setting up the supply for the screen, right? The screen supply, which is via these 1K resistors here. And on the other side of this guy, we're heading off to this side of this 10K dropper here, and that's the node which is powering the phase inverter. So here's our 100K and 82K plate resistors for the phase inverter supply. So this whole section, plate, B+, screen supply node, phase inverter are all tied together. And then from this point, which is where we were, right, we go through this drop-in resistor here, and then it goes all the way over to here, which is setting up the B+ supply for V2 and then V1. And you can see that these drop-in resistors are 4K7 and 4K7. In a standard Marshall Plexi, this would be 10K, 10K all day. The reason that these are 4K7 is because the voltages in this amp are so low that if we were doing 10K and 10K here, the voltage that V1 would be getting, it would be too low. So let's measure those voltages now. Okay, so the amp's powered on. I am just letting it warm up so that I can start getting some readings here that are sensible. Okay, so this is the plate voltage on pin 3. Okay, 296. Now in a standard, you know, a 50 watt or 100 watt plexi, you'd obviously be, you know, 460 plus. I mean, depending on the era exactly. There were obviously the 50 watters for a period there in the JMP era that had quite low voltages, but even those were higher than this. Right, 295. And if I move across to the what the phase inverter is getting, all right, this is the phase inverter node here, 273. Now you would expect to see, you know, the sweet spot here in a plexi for me is 320. You know, 310, 320, somewhere around there. So it's a bit low. And then, as I said, if we move across and look at the supply nodes here, that's for V2, and this is for V1. Now, in a 50 or 100 watt plexi, 258, it's about right, actually, as a supply for V1. So even though the voltages here are kind of low, because we're only using 4K7 droppers, we end up at V1 in a pretty okay place. Now, what I want to demonstrate next is just this cathode bias setup, and we're obviously in the high voltage mode. I will switch this to low and show you what's going on with the voltages there. But I want to do a cathode bias calculation. Right, we'll use Rob Rubinetti's bias calculator. But let's just take the measurements first, right? So here is our plate voltage. We'll record that at 294. And this side of this 150K, this is the cathode resistor, and it's measuring 18.8. So let's punch those numbers in, and we'll see where these EL34s are biased at. Okay, so just a final voltage check. I'm going to flick this to the low power mode, and let's have a look what's going on. You know, voltage, as you can see there, have dropped to 180. I'll check the cathode resistor as well, so we can do another bias calculation here. Let's call that 11. Okay, and let's have a look at what's going on with the phase inverter supply. Really low now, right? Super low. But we'll see that the supply for the preamp is higher. Right, this was 265 before, nearly 20 volts higher. So it changes the sound of the preamp. Right, so dropping the voltages in this thing to low power mode obviously reduces the available power in the output section. And the phase inverter is adjusting down accordingly so that the phase inverter is not smashing the grids of the power tubes too hard. So it's trying to kind of scale them both down at the same time. But by doing so, we're getting a voltage increase here. And the reason for that is because we're not asking the power transformer to deliver as much current. So changing the supply voltages, the B plus supply voltages for the preamp, will actually change the tone of this amp. Higher voltages can sound a bit, they're certainly bolder, but also more strident, not necessarily as sweet sounding. So I believe this amp will always sound better in the high voltage mode. Okay, so now I'm going to make these changes, right? I'm going to take these out in favor for the 2K7s. We're going to put, a fat cap style cap over this cathode resistor on V2A, and I'll do something probably on here with plate snubber to take a little bit of harshness out of the amp. And we're going to put it through, going to reamp it, right, with the loop that I've already saved, the Stone Temple Pilots track, and we'll do an A/B. So let's go through the mods, right? So here we got 2K7 and a 2K7 in here. So I was actually able to do this without lifting the board out. If you want a tip about how to do that, this is all lead-free solder. It's really difficult to work with. So what I do is I use my good old lead tin solder here, and I will, let's just say I wanted to get this resistor here out, I will actually put an amount of this solder on the pad, right? Leave the iron on the pad, wait for it to heat through, and very gently with the iron on the pad, just start to wiggle this, and you'll feel that the leg of the resistor comes free, and you can very gently pry it out. Don't pull it, because you pull it hard, the whole pad on the PCB will come out with it, and you do not want that, because then you're into PCB repair work, pain in the ass, right? So 2K7 here. It's a 22 microfarad electrolytic cap, right? So these are polarized. You're going to have the negative side of the cap to the ground. And here is a 470 picofarad ceramic plate snubber, which is across this 100k plate resistor. In this clip, I will show you the part numbers for these 1, 2, 3, 4 parts, right? Simple as.
So let's go through the parts that I use in this very simple mod. These are the Vishay resistors that I'm using. You'll see these resistors actually in kind of the SLO, and John Sear uses these, bunch of other amp manufacturers as well. It's the CCF60. They're 5-band resistors. They're a little bit pricey, but they are cool. They're great with these Marshall boards because the legs on the resistors are quite thin, so it makes it easy to kind of get them into the pretty thin holes that are on those PCBs. So this is the 2.74K. You can see they're out of stock at the moment, right? But within a few months from now they'll be back in. There is obviously other suppliers you can get these from. You can use any 2K7 resistor you like. I'm just going through the ones that I used in the mod. This is the 22 microfarad 63 volt electrolytic cap, the Nishikon that I used in the mod, right? That's the one that's kind of the the fat cap style mod, sitting over the cathode resistor of V2A. And last but not least, this is a 470 picofarad, which is the plate snubber that I've got on the plate of V2A. Okay, so these are the 562A. You can use any 470 picofarad ceramic here, right? Or just the Vishay ones that I'm using at the moment, but I've tried other manufacturers and they're also fine. So in terms of the A/B test, guys, look, I'm really interested in your thoughts. Which one of the the stock amp or these couple of mods that we did it improve the sound? Did it make it worse? Did it make no difference at all? Leave your comments. I'd love to hear what you think. For me, it delivered what I was hoping for. Pretty subtle, but a little bit more clarity. Take a little bit of harshness out of the stock amp, and a little bit more bold, or a little bit more fatter, I guess, through the mid-range, which is what I was looking for. So these changes actually will stay in the amp. So I to do the Jose mod that I'll be doing with this amp, and I'll feature in kind of a second clip on this SV20. These changes are actually the starting point for that mod. So rather than just complete the mod and not do this test, I wanted to kind of implement these changes and see if we could make the stock amp just sound a little bit sweeter. I hope you thought it was slightly better as well. So the next time we see this amp, it should be a bit of a fire-breathing, high-gain Jose SV20 style. So stay tuned for that. Hope you enjoyed the clip today, guys. And if you haven't subscribed to my channel, then please consider doing so. Give me a thumbs up, hit that like button, and I'll see you next time.